Hi, today's notes is 3.4 rates. Our first objective is solve problems that involve two objects traveling in opposite directions. Example 1 says, in practicing maneuvers, two fighter jets fly towards each other. One flies east at 582 miles per hour, and the other flies west at 625 miles per hour. If the two are 22 miles apart, how much time would it take for them to meet? Okay, this type of question, which is they call it the rates, actually have a special way of doing it. Now, the most important thing is to draw a picture here so you have an idea. Are they facing each other? Are they going away from each other? So if you want to, you can flying towards each other. Here's my plane flying towards each other. Okay. Now, the jet going towards the other way is at 582 miles per hour, and the other one is facing the other way is at 625 miles per hour. So in this case, you can actually see they are going towards each other. Now, when it goes towards each other, if the two are 22 miles apart, that means when you started, this is 22 miles apart. Now, so because of that, you had to think about this. So when the question say, how much time would it take for them to meet? So they had to flying at the same time rate. So in this case, it has to be 10 from the first airplane or 10 from the second airplane. They have to be going the same time. So in this case, what we're going to do is let t equals the time will take for them to meet. Okay, so t is the time. Well, the t is going to be on both of them. So therefore, because they have to be flying the same time. So now here's the thing. If you guys want to, there's a chart that a lot of teachers use. So in this case, you can have this way. It has categories. And this is going to be the rate. And that's going to be the time. And this is the third thing. It's going to be the distance. And I want you guys to understand, when you're talking about a rate problem is rate times the time is going to equal to distance. So it really is times the time equals distance. Okay, so keep that in mind when you can find all the different pieces. So category, I'm going to say jet number 1, and the second one is jet number 2. Now, if you put the chart in participation of maneuver, two fighter jets fly towards each other. Okay, one flies east at 252 miles per hour. So if you want to, you can even say this is at east, and if you want to, you can even say this is westbound. Now, the rate for the eastbound airplane is going at 582 miles an hour, and the westbound flight is going to be 625. Now, the time, we don't know how long they've been flying because that's what the last sentence was asking. Hey, how much time would it take for them to meet? They have to be flying the same time. So therefore, I'm going to put time here. And the distance is, again, I told you guys above, rate times time equals distance. So that's going to be 582t. And the next one is 625t. Okay, now, if you can fill out this chart, you are almost halfway there. The last thing it says, if the two are 22 miles apart, that means the distance from the first flight from here to here, okay, they are 22 miles apart. So that means it's going to be this piece right here, the eastbound plus the westbound. It's going to be 22 miles just because this is one piece plus this piece, and therefore together they are 22 miles. So that's what I'm going to do. I'm going to say 582t plus 625t, that's going to equal 222. Now combine like term, you should get 582 plus 625, that's going to be 1027t equals 22. Now you divide by 1027 on both sides. T is going to be 0.0214. And that's 0.02 hours. But they want to know what's the distance. How much time would it take for them to meet? Well, it'll be 0.02 hours. And if you want to check, you can actually take 0.02 times 582 and 0.02 times 625. They will be a little bit off. Objective 2. Solve problems involving two objects traveling in the same direction. So if they are traveling in the same direction, they have to travel the same distance. Okay? Carol and Richard are traveling north in separate cars on the same highway. Carol is traveling at 65 miles an hour, Richard at 70 miles per hour. Carol passes exit 102 at 1:30. Richard passes the same exit at 1:45. At the time, will Richard catch up to Carol? So in this case, if you're going to catch up to someone, first of all, they have to be traveling the same distance. And then because of that, we need to figure out how much time does it necessary to do that. So right here is going to be the t, okay? And then because of that, we need to figure out how long does it take Carol to travel the same distance. Well, Carol passed the exit at 1:30 and Richard passed at 1:45. Carol has another 15 minutes more before Richard catches up. We gotta change that 15 minutes in terms of numbers so we can do the calculation or in the t. So we need to say, okay, the 15 minutes of the 60, that's a quarter of it, and that's about 0.25. Okay, a quarter is 0.25. Even though it's 15 minutes, but it's a quarter of 60 minutes. And that's why you have to think about it. We are still going to use the same timetable, rate times time, the rate times time equal distance table. So you have a category, and you have a rate times the time. That's going to be the distance, okay? And the two category is going to be Carol's driving, and then you have Richard's driving. And the rate for Carol is 65, and Richard's is 70. Now the time is the tricky part. The time is Carol is already passed, and Richard is catching up. So since she passed, you gotta give Carol the extra time to travel that much further. So t plus 25. And down here is t. Okay, so Richard is a time because Carol travels a quarter of an hour, which is 15 minutes more than Richard in distance wise. So that's going to be 65 times rate times time. Again, rate times time equals distance. So that's 65 times t plus 0.25. And that's just going to be 70 times t. Now, also understand, if they say catch up, right here, That means catch up, they have to at the same place. Now because of that, you are going to let 65t plus 0.25 equals 70t, because both distance has to equal to each other, so they will catch up. All right. Now once you do that, you have to do distribute property because you saw a parenthesis, and to distribute that, you are going to have 65t plus 16.25, that's equal to 70t, and minus 65t on both sides, you will have 16.25 equals 5t. And divide by 5 on both sides, t is equal to 3.25. That means Richard can catch up to Carol is 3 hours and 15 minutes because that's a quarter of the time. And just so you know, that means Carol traveled 3.25 plus 25, which is 3.5 hours. Now 3.5 hours is not the same thing as 3 hours and 50 minutes. It's 3 hours and 30 minutes. So I want you guys to think about that. And if you still have questions, talk to me tomorrow. One more thing. We're going to talk about the procedure. The procedure says two objects travel in the same direction. To solve problems involves two objects traveling in the same directions in which the object is to determine the time for one object to catch up to the other. 1. Use a table to organize the rate and the time. Let t represent the time for the object to catch up, and add the time difference. In this case, was the 15 minutes between passing the exit at 1:30 and 1:45. But that needs to be changed into calculation. So that 15 minutes is really a quarter of the time, okay? And then after that, add the time difference to t to represent the other object's time. 2. Write an equation that is the sum of the individual distance equal to the total distance of the other one, okay? 3. Solve the equation. Hope this helped summarize this type of problem. One of them we have done is opposite. You add them together equals the total. This one is going the same direction. You have to make sure you set them equal to each other. Hope this helped. Thank you so much for watching. Your homework is as follows, starting right here. Okay? Thank you so much for watching.